Well, if you have 5 apples and add 3 apples to it, then you have 8 apples. Oh, okay. Good morning, fellow mathematicians. Welcome back to another video. That's already the last episode on the playlist of sets of numbers. Play the sad background music now. And like promised before, we are going to do a little practice session today, making use of a lot of facts that we have used before, that we have introduced before, I should rather say. So try it out for yourself, take a piece of paper, and here are the following exercises. Pause the video, and after you're done, try checking for the solutions here, alright? So simplify the following expressions as much as possible. Those are the expressions. That's supposed to be a b. Really doesn't matter if you make a 6 out of it. Really doesn't change the point of the exercise. So simplify those expressions, and then there's a second exercise involving fractions. Sort these fractions from the biggest to the smallest. And you really have to think about what 5 is. I mean, it's not really a fraction, but it is also a fraction. I mean, integers, natural numbers are also fractions, basically. So yeah, think about it, try it out for yourselves. We are going to give it a shot now. So simplify the following expressions as much as possible. Negative 1/3 minus 5/3. At first you might see a little observation here. We have negative signs in front of each and every term here. So maybe think about what a negative number actually was. A negative number, for example, negative 5, was nothing but negative 1 times 5. So let's rewrite this expression here, the sum, as the following. This is nothing but negative 1 times 1/3 plus negative 1, okay, minus times plus is going to be negative. We had covered this before. I did a little proof, you could say, on the integers video, so negative, and then times 5/3. And you know, the really cool thing is we can make use of the distributive laws now that we have in the integers and also in the rational numbers. Negative 1 is the common factor, so let us reverse the distributive law. Let us factor out the negative 1 as a common factor of this sum. So now we have negative 1 times what we have in here. And now we are going to add fractions together. Cool thing is we have the same denominator, and this is the really good thing, okay? This is the really easy part if you have the same denominator. You could also factor out 1/3 on both terms, because 5/3 is nothing but 5 times 1/3. You could factor it out, and then you have 1 plus 5 times 1/3, and that would be the same thing. So we are going to add fractions together, giving us negative 1 at first times, okay, same denominator, over 3, and then 1 plus 5. 1 plus 5, we know, in natural numbers, is nothing but 6. Let me erase this and let's put a 6 here. 6 is nothing but 2 times 3. So this makes 2 times 3. And now we have a common factor on 3 on both the numerator and denominator. And now we have 2/1. 2/1 is a special case in the rationals when we have a denominator of 1, which is just a subset of the rationals, namely the natural numbers or the integers. Meaning this is just 2. 2 times negative 1 is by definition just negative 2. And then we are done with the first exercise. That was easy, right? Just making use of the most simple and basic rules we have introduced before. Let us move on with this. Negative 3 times parentheses 2/6 minus 3/6. Okay, so we could distribute the negative 3 into here, making use of the distributive laws. That would work out, but we could also do it a bit differently. We could at first bring those two fractions together and then multiply everything with negative 3. Let us do that. So negative 3 will stay how it is, times. We have the same denominator, that's the easy case. And then 2, and it doesn't matter if you have a plus or a negative sign there, you're just going to add it or subtract it together. So 2 minus 3 is going to give us negative 1. Now we have learned before that a fraction, like I said, for example 5/6 is nothing but 5 times 1/6. So negative 1/6 is nothing but negative 1 times 1/6. Meaning we can just bring the negative sign to the front. So this is negative 3 times negative 1/6. Negative times negative, we have proven this before in the video, why this is the case. It's going to be positive. So we are going to end up with 3 times 1/6. 3 times 1 6 is nothing but 3 over 6. 6 is nothing but 2 times 3, cancelling out the 3's, gives us 1/2. And then we are done, alright? Just basic arithmetic we are doing here. Basic algebra, really easy stuff. Now next up, 5a plus 3a times 1/4 plus 2/4. Alright, so teacher would tell you that just bring those terms together, alright? And well, if you have 5 apples and add 3 apples to it, then you have 8 apples, oh, okay. But we want to do this a bit more rigorous. Why is it even the case that 5a plus 3a gives us 8a? You could also use the distributive laws twice, okay, putting everything into everything, but we're not doing this here because there's a way easier way. Let us start with 5a plus 3a. Why is this 8a exactly? Well, a is a common factor on both of those. Let us factor out the a using the distributive laws, meaning this is a plus times 5 plus 3, I'm terribly sorry, times what we have here, alright? So 1/4 plus 2/4. 5 plus 3 is going to give us 8. So this is 8 times a. Now 8 times a. This is just making use of the distributive laws. This is just what it is. Okay, this is where all of this comes from with adding same variables together basically. Now what we have here are fractions yet again. Okay, I'm torturing you with a few fractions because this is what most students have enormous problems with, fractions. And we are just going to do it over and over and over again. After this sets of numbers playlist is over, we are going to start with exponentiation and fractions, and it's going to be an immensely huge playlist. So 2 immensely huge playlists, but they are so important you just need it all the time later in the game. So yeah, watch it, it's going to be important if you don't know already about all of this stuff. So we have the same denominator here, 4, just adding fractions together. 1 plus 2 is going to give us 3. Alright, so 8, we can multiply it up here, this is just what a fraction is. We are going to leave the a alone. A times 8 times 3 over 4. 8 is nothing but 2 times 4, cancelling out the 4's, gives us 2 times 3 over 1. Over 1 really doesn't matter, we are just in n then, so this gives us 6. So meaning overall, this is 6 times a. Okay, try it out for yourself. Take a piece of paper, try it out, write everything out with me, okay, while we are doing this shit here. Now, last exercise. Negative a times negative 3 times negative b. Let's just go ahead and get started. Last video we have learned that negative times negative is positive. So let us go ahead and get started with negative a times negative 3. It's going to give us 3 times a times negative b. Now, 3 times a times negative b. Just multiply everything out. I mean, negative b is nothing but negative 1 times b. Make use of the commutative laws with respect to the multiplication, bring negative 1 to the front, and then voila, you are going to get negative 3ab. Really doesn't matter if a is positive or negative. For now it's just a variable, so you really don't know if you get a positive or negative sign out for now. But keep the negative sign here, it's important. Okay, unless you know what the variables a and b actually are. And thus we are done. Really easy, right? So triple negatives gives you negative yet again. Good to know. Maybe we need this later when it comes to exponentiation. I don't know. Maybe I do know. Never mind. Sort the fractions from the biggest to the smallest. I know there are many strategies out there to do something like this, but we are going to go by the strategy I have proposed in the chapter about fractions. Alright? So meaning, if we want to compare, for example, 5 and 3 over 4, which is bigger, which is smaller, then what we did is we multiplied both sides of the unknown equation of the inequality by 4, giving us 20. Okay, 5 times 4 is 20. And then a 3 on this side. 20 is obviously greater than 3, meaning overall, by putting everything back together, 5 is also greater than 3 over 4. That was the strategy, and we are going to do this with all those numbers. We have a lot of numbers here. We have a whole set of numbers, 5 numbers in total, and what we are going to do now is we are going to multiply the whole set of numbers by those factors down here in the denominator, one after another. We are going to get rid of the denominators, and thus we can compare each and every slot, you could say, by their size. And then we are going to have a list of integers down here, and we are going to write everything nicely under each other. And then, for example, if we get 16 out here and for example 21 out here, then we know that 21 is greater than 16 and then we can sort everything. So let us go ahead and get started, and let's just start from the left. 5 is already nicely shortened, okay, so there's nothing to cancel out anymore as a fraction. So let us multiply this whole row by a 4 to get rid of this 4 down here in the denominator. Meaning, if we were to multiply 5 by 4, it's going to give us 20. And then 3 over 4 times 4 is going to give us 3. We want to get rid of the 4, so it just makes sense, right? Now, we are going to get, okay, negative is going to stay how it is. We are going to get 4 over 6. I'm terribly sorry. 4 over 6, we multiplied everything by 4. Now 4 is nothing but 2 times 2. Let me write everything out. 6 is nothing but 2 times 3, meaning we have a common factor of 2 cancelling out. So all that's really left here is 2 over 3. We are going to do the same thing on all the other two fractions that we have. So negative is going to stay how it is. Multiplying this by 4, okay, 3 is going to stay. And then 4 is nothing but 2 times 2. 2 is cancelling out, meaning only thing really left is 2. So 2 times negative 3 is going to give us negative 6. I hope you could follow everything I said here. Like I said, take a piece of paper to write it out for yourself. Negative 6, alright. And now, multiplying this by 4, factor of 2 is going to die in the process. So we have 11 times 2 giving us 22 overall. And that's kind of brilliant, right? With this small and intelligent move, we got rid of basically all fractions except for this one. Now we are just going to, well, multiply this whole row by a 3, and then we are basically done and can start sorting out. So multiplying everything by 3 gives us 60, 3 times 3 is 3 squared. Okay, we are right where we want to go, okay? Exponentiation, so this gives us 9, 3 is going to die in the process, so negative 6. And then negative 6 times 3, negative times positive is negative, meaning negative 18. And then, no, it's going to give us negative 2 here because we get rid of the 3 right here. I'm terribly sorry. I saw the mistake just in time, alright, so we are going to get rid of the 3 down here, but the 3 that we multiplied everything with is not going to affect our 2 up here. So I'm terribly sorry about that, comma, and now 22 times 3, that's kind of hard, okay, 66. Alright, now we can start sorting, and let's see which of those numbers corresponds to which up here originally, alright? So, which one is the biggest number here? Well, obviously 66 is the biggest number that we have here, meaning 66 corresponded to 11 over 2. Now, that's our biggest number. It's greater than, well, after 66 comes 60. 60 corresponds to 5. And this is indeed the case because 11 over 2 is a bit more than 10 over 2, which is 5. This is 5.5. Decimal stuff, we are going to talk about this in a completely different playlist, alright? So 5.5 is indeed greater than 5. Next number is the number 9, alright? Number 9 corresponds to 3 over 4. 3 over 4 is nothing but 0.75, alright? 5 is indeed greater than 3/4. This is greater than, okay, which one is actually greater, negative 2 or negative 18? You could go back to the integers playlist and the order there. I have told you about a few things there when multiplying both sides of an inequality by negative 1, but you can just go by, for example, that yet again. So 18 is in normal case greater than 2, but if you have $2 of debt, then you have less of a debt than if you would have negative $18 of a debt. So meaning negative 2 is indeed greater than negative 18, but those numbers correspond to 1/6, so negative 1/6, and negative 18 was exactly a negative 3 over 2 here. Negative 1/6 is something like 0.16, so negative 0.16, and negative 3 over 2 is negative 1.5. So it makes perfect sense. And thus we have ordered those fractions by their size. And I hope you enjoyed this video. If you did, please like, subscribe, recommend channel if you like. If you want to support channel a bit more by those teachers I create, or support channel on Patreon, tell your teachers, your other students, your classmates about this channel if you think they could benefit from the content here. And I think I'm going to see you in the next playlist about exponentiation and fractions. But up until then, I wish you guys a flammable day. See ya!